Hello friends, today I am going to explain about thin layer chromatography or TLC. It is a rapid and simple chromatographic technique used to separate and analyze mixtures of compound by separating them based on the difference in affinity towards stationary phase and mobile phase. Usually in a TLC, the stationary phase is a solid adsorbent coated on a stationary support such as glass or plastic. During chromatography, the mobile phase distributes the compound present in the mixture over stationary phase, that is adsorbent, and the mobile phase is known as eluent. The TLC plate is made up of glass, metal or plastic, which is coated with thin layer of solid adsorbent, usually silica or alumina. Then a small amount of mixture to be analyzed, that is sample, is spotted near the bottom of the plate. The plate is then placed in a shallow pool of solvent, that is mobile phase, in a developing chamber. This mobile phase or eluent slowly raises up the TLC plate because of capillary action. The mobile phase may be a pure solvent or a mixture of solvents. Different molecules are carried up the plate to different distance due to variable interaction with adsorbent material. For example, when silica is used, polar molecule with groups such as hydroxyl group or amine NH2 group will tend to form hydrogen bond with silica matrix. Hence, it will not move as fast up the plate, while relatively non-polar molecule will have fewer interaction with the matrix and will tend to be more soluble in the mobile phase and therefore rise up faster with the solvent front. Next is solvent selection. Because of toxicity, cost and flammability concern, the common solvents that used are hexane and ethyl acetate. Diethyl ether can also be used, but it is very flammable and volatile. Alcohols such as methanol and ethanol are also preferred. Acetic acid can also be used, but usually in small percentage since it is corrosive, non-volatile, very polar, and sometimes it can cause irritation. Methylene chloride and chloroform are also good solvent, but are toxic, hence should be avoided whenever possible. If two solvents are equal in performance and toxicity, the more volatile solvent is preferred because it will be easier to remove the solvent after separation. Next is adsorbent. Valence electrons at the surface of a solid absorbent are not saturated by adjacent atom, and to certain degree they are available for bonding. The substances that are polar or polarizable undergo an electrostatic attraction to these electrons. So the substances are getting adsorbed on the stationary phase. There are different types of absorbent available for TLC. Most commonly used are silica and alumina. Addition to that, Kieselguhr, zeolite, cellulose powder, iron exchange cellulose, starch, polyamide, and Sephadex are also used. This picture shows different steps in the chromatogram development. So, first you have to cut different strips which is available ready-made. So TLC strips is shown in the figure. Similarly, you have to take the solvent, it may be pure or a mixture of solvent, take it in a beaker and keep it closed like this. The strip you have to mark at the bottom, about 0.5 to 1 cm away from the bottom. You have to draw a line and mark sample number 1, 2, 3 like this, and using a capillary tube you can spot your sample as well as standards on the TLC plate. In the first picture, you can see that the sample and standard is spotted on the plate. Now, you can place this strip inside the developing chamber or beaker. So it is immersed in the mobile phase. But the spots should not touch the mobile phase. That will avoid the mixing up with the solvent. Then allowed to develop for some time. Before reaching the solvent at the tip, you can take it out and then dry it. So you can see spot like this if it is a colored compound. If the separated compounds are not colored, we have to visualize using different visualization technique. So most of the cases UV light will be using. TLC plate normally contain fluorescent indicator which make the TLC plate glow green under UV light at wavelength of 254 nanometer. Simply put the plate under UV lamp so the compound became visible to the naked eye, because the compounds that absorb UV light will quench the green fluorescent, yielding dark purple or bluish spot on the plate. Another method for visualization is iodine chamber. You have to keep your plate after developing and drying inside a closed chamber and put some iodine crystals inside that. Iodine sublimes and will absorb by the organic molecule in its vapor phase. So the organic spot on the plate will turn brown and hence can be identified easily. Then circle the observed spot since the color stain will eventually fade off after some time. Sometimes a combination of UV and iodine is needed for observation of all the spots. There are different types of visualization techniques available other than these two. For example, ninhydrin is commonly used to spray to identify amino acid spots in a TLC plate. After marking spot, we have to identify RF value or retention factor. Our retention factor is defined as the distance traveled by the compound divided by the distance traveled by the solvent. So, after immediately after taking the plate from the mobile phase, you have to mark solvent front. Then you have to mark the spot as explained earlier. Then find out the distance moved by the sample from the point of application. Similarly, find out the distance moved by the solvent. The distance moved by the sample divided by distance moved by the solvent will give you the RF value. For example, if a compound travels 2.1 centimeter and the solvent front travel 2.8 centimeter on a TLC plate, the RF value will be 2.1 divided by 2.8, that is 0.75. The RF value of a compound is constant for one experiment to next only if the chromatographic conditions are constant, like solvent system, adsorbent, thickness of the adsorbent, amount of material spotted, and temperature. Otherwise, there will be a slight difference in the RF value from experiment to experiment. This TLC technique can be used to separate food colorants. Here, a propanol water mixture can be used. So, see you soon with another video. Thank you.